Hello everyone, to this lecture about the determinant. So we define determinant for matrix A, a 2 by 2 matrix A, which is the number that equals AD minus BC. So we note the determinant by det A, so like this, or by these two bars instead of this bracket. So this is the notation for the determinants. They are the same. So and the determinant is equals the multiplication of the main diagonal of this 2 by 2 matrix minus the product of this of main diagonal entries. This method is valid just for the 2 by 2 matrix. We can't apply it for bigger matrix. To get the determinant for a bigger matrix, bigger square matrix, for example n by n, we need to compute something called the minor of each entry of this matrix. So, for example, in this matrix A 3 by 3, which is equals, for example, A11, A12, A13, A21, A22, A23, and A31, A32, and A33. So this matrix. So we need to compute the minor for each of these entries. For example, for the first entry here, A11, we need to compute M11, and to compute it, we need to delete the row and the column that contain it. So we'll delete this row and this column and compute the determinant for this remaining matrix. So we'll compute this, for example, like the example here, M11 here is, we need to delete this row and this column that contain A11 and compute the determinant for this remaining matrix. So it will be the determinant of A22, and this is a 2 by 2 matrix, so its determinant is it's easy to get its determinant by this method here. And to compute the minor for this entry here, we need, so for example, M12, we need to delete this column and this row. For example, let me erase this for the M11. So to compute the minor for A12, we need to delete this column and this row, and we will get this entries for a new matrix. They will be A21, A23, A31, and A33. So we need to compute the determinant of this 2 by 2 matrix, which is this one times this one, so A21, A33 minus A31 times, so A31 times A23. And in this case, we get the M12. And we do it for each of these elements. So to compute, for example, this one, we delete this row with this column, and we take these elements and get their determinant, and so on. For each entry, we need to get their minor Mij. And we also need to define the cofactor of each entry of this matrix, or to compute the cofactor of each entry of this matrix. And the cofactor denoted by this notation, Cij, for example, C here, or C11, for example, is defined by this formula. So it is -1 times power of I plus j Mij. So it is equals Mij when this is an even number, for example, multiple of 2. However, if it is an odd number, it will be the negative of the Mij. For example, in this case here, Cij will be equals M11, because here we have 1, so it will be -1 times 1 plus 1, which is 2, so 1 minus 1 square is 1, so it is equals M11. And in this case here, M12 will be equals or C12, so I mean C12 will be equals minus M12, because here we have -1 times I here is 1, so it is 1, plus G here is 2, so it is 2, which is minus 1 times 3, which is minus 1. So this is minus 1, 2. And for example, for the matrix A here, we can compute 1, 1 here, for example, which is the 3 here. So to get 1, 1 here will be the m of this 3. So we'll need to delete this row with this row. So it will be the determinant of 5, 6, 4, 8, which is equals 5 times 8, which is 40, minus 4 times 6, which is 24. So this is 16. And the m, for example, of any other element, for example, let's choose this 5. For example, this 5 is 2, 2. So it is m 2, 2, which is equals, delete this row with this column, and we stay with this here, 3, 1, 3, 1, and minus 4, 8, minus 4, 8, and the determinant is 3 times 8, which is 24, minus here 1 minus 4 is minus 4, minus it will be plus, so plus 4, which is 28. And for example, the 4 here is m 3, 2. So it will be, delete this column with this row. So all the remaining will be 3 and 2, 3 and 2, and minus 4 and 6, which is equals 3 times 6 is 24. Here 2 minus 2 times minus 4 is minus 8, but minus minus will be plus, so plus 8, which is 32. And here, for example, C11 here will be, C11 here, for this example here, will be C11 equals minus 1 times 1 plus 1, which is 2, so minus 1 square is 1, so it is M11, which is equals 16. They are equals in this case. And M22 here will be, so C22 here will be equals minus 1 times 2 plus 2 is 4, so it is 1, MIG, so in this case it is 28. And here, for example, C32 is equals minus 1 times 3 plus 2, which is minus 1 times 5, minus 1 power 5, times M32, which is 32, so it will be times 32, which will be minus 32. So this is how we get the cofactor and the minor for each element, and we need to compute it for each of these elements. And in the next slide I will show you how to get the determinant from the cofactor and the minor, and we will also see other examples to get the determinant. So once we get the cofactors for matrix A, we can get the determinant by the product or the sum of the product of each entry. So we will go with one row or one column. So for example, if we have this matrix, we will go with this row times their corresponding cofactor. For example, the determinant of this matrix here is A11, C11. So we will go with this first row here, and it will be A11, C11, and A12 with their corresponding cofactor C12 plus A13 times its corresponding cofactor. And we can take any row, so they are all will be equals. There is no difference between them. We can also take this row, for example, here, like here, so it is 1, 2, 1 times its corresponding cofactor plus A22, C22, so here, and A23 times its corresponding cofactor to 3. And also for the third row, the same here, for example, equals it. And we can also get, so let me read these lines here. We can also get it by going with columns. For example, for the first column here, A11, A21, A31, so we have A11, its corresponding times its corresponding cofactor plus A21 times its corresponding cofactor C21 plus A31 times its corresponding cofactor 31, and so on for each column. Also here, for example, the second column here, and the third column here, for example. So this is the definition here. So we can go with any row or any column that we chose. There is no difference between them. We will get the same result always. Once we compute the minor Ig and then the cofactor Cig, we can get the determinant easily by this formula. And I will do an example for it in the next video.